Hello everyone and welcome back to yet another video from my channel Interactive Education. And today we are going to start the mathematics revision sessions for the class 10th SA2 board examination. And this is on demand because many people have been telling me to revise important questions from various chapters. So I'm going to collect questions from various sources, get the best questions and put them here. And we're going to solve those questions. So I will not be actually going over concepts, but we will be going over some good questions, right? So I'm assuming that you know the concepts, but we're going to go over some good questions. So quadratic equations is the first chapter we're going to take up. And you know, a quadratic equation is an equation with the degree 2 where the leading coefficient is non-zero. So any equation of the form ax square plus bx plus c is equal to 0, where a is not equal to 0 is a quadratic equation, right? Any equation of this form where x is the variable. This is an equation in variable x. So that's the basic definition of a quadratic equation, right? So now we're going to go on to some important questions, right? Then we're going to take up some important concepts like factorizing the middle term. So factorization method for solving the equations. We're going to take up this method. We're also going to take up the concept of discriminant, right? And how discriminant is important in determining the nature of the roots, where d is equal to b square minus 4ac. We are also going to take up word problems. So these are the three most important topics for the examination: factorization, discriminant, and word problems. They may ask you sometimes for method of completing the square, but I've not seen that for many years. So I'm not really going to take up that. But if you still want me to explain the question on that, once we are going to take up a maths live session before the exam, you can take up the queries there for any chapter, right? So we're going to start without any further ado on quadratic equations. Let's start off. So first we have this basic question. It's a very basic question. They're saying that for what value of k does the given equation have real and equal roots? Now this is the given equation. K plus 1 into x square minus 2 into k minus 1 into x plus 1 equal to 0. So we need to find a value of k for which the equation has real and equal roots. So this is our given equation, right? Now you know that if an equation has real and equal roots, if an equation has real and equal roots, then what is the condition? D needs to be equal to 0. The discriminant value needs to be equal to 0. So b square minus 4ac equal to 0, because there are, you know that there are three cases. If d is greater than 0, then they have real roots. If d equal to 0, real and equal roots. And if d less than 0, then unreal roots or imaginary roots. So if an equation has real and equal roots, then d has to be 0. So b square minus 4ac equal to 0, b square equal to 4ac. Now in this equation, what is b? B is minus 2 into k minus 1. What is a? K plus 1. And what is c? 1. That's it. So now substitute, easy. Minus 2 into k minus 1 whole squared is equal to 4 into k plus 1 into 1. So this becomes 4 into k square plus 1 minus 2k is equal to 4k plus 4. Now this is a very basic question, right? Because you know I have squared this, minus 2 whole square becomes 4, and then square of this is a minus b whole square. So a square plus b square minus 2ab, right? So now you can take the 4 common and actually cancel the 4 here. So you will get k square plus 1 minus 2k is equal to k plus 1, because I've basically taken the 4 common here and cancelled it. So now you just solve this equation. Again, you'll get another quadratic equation. What do you get? You get k in terms of k. So k square minus 2k minus k plus 1 minus 1 is equal to 0. So this plus 1 minus 1 get cancelled. You get k square minus 3k is equal to 0. please don't do the blunder of just taking this here, because then you will get only one value for k. We have to get two values for k. So take k common here. K minus 3 is equal to 0. Therefore, k equal to 0 or k minus 3 equal to 0, because any one of them has to be 0 for the product to be 0. Therefore, k equal to 0 or k equal to 3. This is the answer for this equation. Either the value of k is 0 or the value of k is 3. Any one value will satisfy. Even if you take 0, it will be 0 plus 1, which is x square. So definitely it is still a quadratic equation. So k equal to 0 or k equal to 3. Right? So in this way, you will solve this equation. Right? That's it. Discriminant concept, easy. So these 3Ds, please remember these three cases, right? These three cases are very, very important. Once you're done with that, perfect. Right? Let's move forth. Now the next question is a factorization question, and here you need to use the factorization method to solve this equation. The equation is solve for x, and the equation is 4 root 3x square plus 5x minus 2 root 3 equal to 0. Now you know that in the factorization method, the first step, or even before that, first let's mark the coefficients. You know a is 4 root 3, b is 5, and c is minus 2 root 3. So we got that right? These are the coefficients. Now, you know that in the factorization method, the first step is that we need to multiply a and c. So do this in your rough calculations. Don't do this in your fair calculations. Do it in your rough calculations, because you need to determine two numbers, which we will do now. What two numbers? Let's see. So first take AC. AC value is a into c, that is 4 root 3 into minus 2 root 3. How much is that going to come? It's going to come minus 8 into 3, that is minus 24. Right? So minus 24. That's clear? Now, we need to find two numbers such that their sum is 5, but their product is 24. Minus 24. Their sum is 5, but their product is minus 24. Right? Now, it's 5. Sum is 5. That means the positive one is greater than the negative one, definitely. Right? So, their product is negative. That means one has pakka negative. But the negative number is greater than the positive number is greater than the negative number. That's for sure. Now, let's do that. Is greater than the negative number, and it's pretty much greater than the negative number. Their sum is a positive number. So, you know that 8 into 3 is 24, right? Now, if I take 8 into minus 3, it's coming minus 24, right? And if you take 8 minus 3, what is the value? 5. Done. We found our two numbers, 8 and 3. 8 and minus 3, right? Because if we take 8 and minus 3, my question is done. I get a sum of 5 and I get a product of minus 24. Now here it was an easy number, but in some equations, the number is very difficult to find. In that case, draw a factorization tree, a very long factorization tree, and try to find the numbers. That's the best method. It will be quicker, as with practice you will get it. Now, 4 root 3x square plus 5x minus 2 root 3 equal to 0. Now we got our two numbers. So now write the middle term and split it in terms of 8x and minus 3x. So it will be 4 root 3x square plus 8x minus 3x minus 2 root 3 is equal to 0. Now here take 4 common, 4x common. You get root 3x plus 2. Minus, take root 3 common, you get root 3x plus 2 is equal to 0, because this becomes minus 2 root 3, this becomes minus 3x, right? So now you know that this is a common term, so take it common, you get root 3x plus 2 into 4x minus root 3. This value is 0. Now, since this is 0, at least one of them has to be 0. So therefore, root 3x plus 2 is equal to 0, or 4x minus root 3 is equal to 0. Therefore, what do we get? X is equal to minus 2 by root 3, or x is equal to root 3 by 4. This is the solution to this given quadratic equation. Right? So I hope that's absolutely clear how we solve this quadratic equation using the factorization method, right? You take the product of the first term and the constant term. This is usually done when the first term coefficient is not 1, right? If it's 1, then we usually just consider this as our product. But here we have a considerable value as a coefficient, as the coefficient of the first term. Hence, we need to multiply it with the constant term to get the required number whose product should be this and whose sum needs to be the middle term coefficient, right? So I hope that's absolutely clear now how we solve this question. Right, let's move forward. Now we're going to start off from here with our word problems. Now I've made a collection of word problems. So from question number 3 to question number 10, we have very good word problems. So let us solve our word problems now, right? Divide 16 into two parts such that twice the square of the larger part exceeds the square of the smaller part by 164. So we assume that let the two parts, or let the larger part be x and smaller part be y. Now there are two parts, right? There are two parts when we want to divide 16 into two parts. That means we want to divide it into two numbers so that their sum is pakka 16. Their sum has to be 16. So therefore, we can make one equation here that x plus y is equal to 16. That's for sure because it's two parts. Their parts are derived from 16. So their sum has to be 16. So write x in terms of y now. So x is equal to 16 minus y, equation 1. Now I got x in terms of y. So x is equal to 16 minus y, equation 1. Right? Next one. The second condition is also being given to us. They are saying that we need to divide it into two parts such that the twice the square of the larger part. So twice the square of the larger part exceeds the square of the smaller part by 164. That means the square, twice the square of the larger part of 16 exceeds, that is, it is 164 more than the square of the smaller part. So as per given data, what can I say? I can say that 2x square, because twice the square of the larger part we've taken as x. So 2x square is equal to 16 minus y, not 16 minus y. Oh, can't we just rub this? Okay, so back to pen. Now, exceeds the square of the smaller part. Now, square of the smaller part is y square plus it is 164 more than the square of the larger part, smaller part. So 2x square is equal to y square plus 164. That's it. We got our equation. But you're saying but you might be thinking that it's in terms of two variables. So how do we now bring it into a quadratic equation in one variable? Very easy. Substitute the value of x with what we found in 1. So 2 into 16 minus y whole square is equal to y square plus 164. That's it. So 2 into 16 minus y whole square. What is 16 square value? 196. Okay, let me just calculate it quickly. What is the value of 16 square? It's 256. 16 square is 256. It's an important value. Please remember it. Plus y square minus 32y. Again, I'm using the formula a minus b whole square. And this is equal to y square plus 164. Now, let's just open the brackets now on the left hand side. So you will get 2 into 256, which is 512 plus 2y square minus 64y. This value is coming out to be y square plus 164. So now you transpose everything to the left hand side. You get 2y square minus 64y minus y square plus 512 minus 164 is equal to 0. So now 2y square minus y square becomes y square minus 64y plus 512 minus 164, this becomes 402, 392, 382, 372, 362. Oh, no, wait just a second. 512, so 412, 412, 402, 392, 382, 372, 362, 352. So 352, 352, 348. So 348, this value is 0. You got a quadratic equation. Solve this quadratic equation. What will you get? You will get y square minus 64 y plus 348, 0 is equal to 0. Now we got a quadratic equation. Now here the factorization is slightly difficult. So you know that the coefficient term is 1 for the first term, so no need to waste your time there. 348, now we need to factorize. So factorize 348 into two parts. So if you do it with 2, so this will be 2 into 172, right? 172, and not 172 exactly, 174, 174. Then 174 again goes with 2, so 2 into 2 into, this will be 87. Okay, 87. Then can 87 be divisible by 3? Yes, it can. So 2 into 2 into 3 into 29, right? So can we say this, what's the product of this? 2 to 4, 4, 3, 12, right? 12 and 29, 29, 39. No, it is not 64 at all. Then can we say 3 into 29? 3 into 29 will be 87. 87 minus 4, again not possible. Then 2 into 29 will be 49, 58, and then 6. So 58 plus 6 is 64. Yeah, we got it. So we took 2 into 29 and then 6. So 6 and 2 into 29 will be 58. So 58, plus, so minus 58 minus 6 will be what? Minus 64, right? So now solve it. You got our equation, right? So in this way, you need to do factorization. And when you do factorization, gradually you'll get the hang of the thing. So this will be y square minus 58y minus 6y plus 348. This value equal to 0. So now here take y common, you get y minus 58. Minus, take 6 common, you get y minus 58. This value 58, this value is equal to 0. So here you get y minus 6 into y minus 58 is equal to 0. Therefore, what can you conclude here? You can conclude that y is equal to 6 only. Y is not equal to 58. Why is that so? Because we assumed already in the question that y is the smaller part. So y has to be the smaller part, right? And it cannot be 58 because you want to divide it into what? 16. So no chance at all. 58 will be more than 16 itself. So it cannot be 58. It has to be 6. So y equal to 6. Therefore, y is equal to 6. So what will be x? Therefore, x value is going to be 16 minus y, which is 16 minus 6, which is 10. So what are the two parts? It is 10 and 6. Clear? So I hope that's absolutely clear. And you can even, verify this. So 2 into 10 square, which is 100. So 200 is equal to 6 square, 36 plus 164. Does that apply? Yes, it does, because 36 plus 164 is nothing but 200. Right? So I hope that's absolutely clear to you. Right? So let's move on to the next question now. The sum of the, okay, now I like ages questions. I really don't know why, but I really like solving them. So the ages of the son of a father, sorry, the sum of ages of a son and his father is 35 years and the product of their ages is 150. Find their present ages. Pretty straightforward. Now let the son's age, let me assume that the son's age is some x years. And let me assume that the father's age is some y years. Now, they're saying that the sum of the ages of a son and his father is 35. So pretty much I can guess that the father is pretty young. He's not very old. And the son is also very young. So x plus y is 35 as per the given data. Therefore, write one variable in terms of the other. So let me take x in terms of y. So x becomes 35 minus y. Equation 1. Now they're asking you They've also given one more condition, that the product of their ages is 150. So product of their ages xy. So this is implication and this is implication. Now xy value is 150. We need to find their present ages. Now we've been given this condition. So what do we do with it? Substitute the value of x in terms of y, which we found in 1. So you get 35 minus y into y is equal to 150. So you get 35 minus y square is equal to 150. Now transpose everything to right hand side, right? So this becomes y square minus 35, actually this is 35y, 35y plus 150. This value is 0. I've just transposed everything to right hand side and written the equation like this. Okay. So that doesn't make any difference. It's the same thing, right? So we've got another quadratic equation, right? Again, there is no constant term. There's no coefficient of the first term, so only a constant term is there. We're going to use that. So 150, its sum is minus 35 and product is 150. That means both are negative. Both are negative. Sum is negative, but product is positive. So both are negative. So this can be written as 5 into 30. So that's pretty much it. that's it. Yeah. So this was an easy one. So this becomes, just a second, yes, y square minus 30y minus 5y plus 150. This value is 0. So here take y common, again y minus 30 minus 5 common, y minus 30. This value is 0. So here we get y minus 5 into y minus 30. This value is 0. But can y be 30? Can y be 5? No. Therefore, y is equal to 30 years. Since y equal to 5, not applicable. You cannot say that y is 5 because the father's age is y. And you cannot say that father will be 5 years old, then the son will be 30 years old. That's not possible. The father has to be older, so y is 30. Therefore, automatically the son's age x becomes 35 minus 30, which is 5 years. Right? So my final answer, final thing which you have to write in the exam as conclusion is the son's age is 5 years. The father's age is 30 years. Right? So I hope that's absolutely clear. This is what you have to do in this equation, in this word problem on quadratic equations. Right? So let's move forth. 2 pipes. Now again, this is a question which is very important. You have this model of questions in your NCRT. In the NCRT, you get this. There's a question like this, right? And it's a question based on work and time. It's a very, very important concept. Please pay attention to this question. 2 pipes running together can fill a cistern. Cistern is basically a utensil kind of thing. It's a cylindrical kind of thing. 2 pipes running together can fill a cistern in 6 minutes. Right? Together they are running and they can fill it in 6 minutes. If one pipe takes 5 minutes more than the other to fill the cistern, find the time in which each pipe would fill the cistern. Right? So let the time taken, first we should declare the variable. So let the time taken by more efficient pipe be equal to 5 minutes. Sorry, not 5 minutes. Oh gosh. It's not 5 minutes. I'm really, really sorry. Not 5 minutes. We are declaring a variable, right? So let it be x minutes. Right? So we're going to assume that the time taken by more efficient pipe, that is the pipe which fills up the cistern quicker itself, let it take x minutes. So therefore, they are saying that the other pipe which is less efficient will take 5 minutes more because it's taking more time, it is less efficient. So takes 5 minutes more. Therefore, time taken by less efficient pipe will be x plus 5 minutes. X plus 5 minutes, right? Now, we have got this, right? Now, one thing to be noted. Here they are taking that, let me assume the first pipe. Okay, let me take this as pipe 1 and let me take this as pipe 2. Now, if you look at pipe 1 can fill up the whole cistern in x minutes itself. It can fill up the whole cistern in x minutes itself. So, whole cistern in x minutes. So, x minutes, it will fill up the full cistern. But in 1 minute, how much of the cistern will it fill up? How much? Only 1 by x. It will fill up only 1 by x of the whole cistern in 1 minute. Right? Because it is taking x minutes to fill up whole cistern. So 1 minute it will fill up 1 by x part of the cistern. Right? 1 by x part of the cistern. Please remember. The second pipe is x plus 5 minutes it takes to fill up the whole cistern. Therefore, 1 minute it will take how much time? In 1 minute, how much of the cistern will it fill up? Only 1 by x plus 5. Only 1 by x plus 5 of the cistern. Right? So, this is where the trick comes. If you get this idea, you are done with this question. Right? So, these pipes take, in 1 minute, they are able to fill up this much amount of the cistern. 1 by x and 1 by x plus 5 respectively. Now we come to our main part that two pipes together can fill it in 6 minutes. So together they fill it in 6 minutes. So much quicker. Together they fill it in 6 minutes. Therefore, in 1 minute, how much are they able to fill it up? Only 1 by 6 of it. Oh no. Together in 6 minutes, they are able to fill up the whole cistern. So in 1 minute, they will be able to fill up only 1 by 6 of the whole cistern. Right? So, of cistern. That's it. Now, formulate your equation as per given data. The first pipe will fill up 1 by x of the whole cistern in 1 minute. So 1 by x plus, this will fill up 1 by x plus 5 of the whole cistern. 1 by x plus 5 in 1 minute. So with their respective work efficiencies together in action, they are able to fill up 1 by 6 of the cistern. That's it. That's your equation. This is their work efficiency. Together when their work efficiency works, that is rate of filling per minute, how much they fill up per minute there. Together when they sum up, they give you 1 by 6. They are able to fill up 1 by 6 in 1 minute. Right? That's it. If you are able to get this equation, you are done with this question because now you just have to solve it. So solve the equation, you get 2x plus 5. I'm going to solve this quickly. Okay. This will be x square plus 5x. I'm taking LCM. This will be 1 by 6. So I'll be just rubbing this off because I need space. So let me just rub this off. Okay. So this is my thing. Now cross multiply, you get 12x plus 30, because if you take the 6 there, you get 12x plus 30 is equal to, now you take this x square there, you get x square plus 5x. Now just solve it. You're done with this. X square plus 5x minus 12x minus 30, this value is 0. So x square minus 7x minus 30 equal to 0. You get a quadratic equation, and here there's no first term coefficient, but again the constant term is negative. the constant term is negative. So the middle term is also negative. So one is negative while the other is positive, because product is negative and sum is also negative. And the negative one is more in magnitude than the positive one. So let's try that. 30, if you factorize, you get 5 into 6. Not possible. So you do this 2 into 3. So 5 into 6, 5 into 6, so 5 into 2 into 3, right? 2 into 3 into 6 into is not possible. So 5 2s are 10 and then 3. So 10 and 3. These are the two number magnitudes. Now their sign. One has to be negative. So this will be negative. The one greater in magnitude has to be negative because the sum is also negative, and this will be positive. So minus 10 plus 3 minus 7, and minus 10 into plus 3 is minus 30. So you got your two numbers. So you get x square minus 10x plus 3x minus 30, this value equal to 0. So here take x common, you get x minus 10 plus 3 common, you get x minus 10 is equal to 0. Therefore, x equal to 10. You'll get x minus 10 into x plus 3 equal to 0. So x equal to 10. X will not be equal to minus 3. X cannot be minus 3 because time cannot be negative, right? It has to be 10 minutes. So x is 10 minutes. Therefore, the more efficient pipe fills up the tank or the cistern itself in 10 minutes. So how much time will the less efficient one take? X plus 5, right? So that will be, so more efficient takes 10 minutes. Less efficient will take 10 plus 5 minutes, which is going to be 15 minutes. That's it. Question done. Clear? So I hope you're absolutely clear with this question. This form of questions are very, very crucial in your exams. Please be clear with the concept of work and time, which I've just explained. Right? If you're able to formulate equations like this, well, you're done with this question. Right? So in this video, I finished up 5 very good questions from the chapter Quadratic Equations. And this is the first part of the revision session. In the next video, we'll be taking up the last 5 questions. So please look forward to that video. Like and subscribe to this video. And if you have any kind of doubts, please post them in the comment section below. Best of luck for your examinations. Bye-bye. Stay healthy, stay smart, and do keep studying.